Hi everyone! In this module we're going to talk about application programming interfaces, or APIs. And in this lecture we're going to use an example from the Bay Area Rapid Transit System, or BART. So we're going to look at different ways to access data using an API. We're going to use the requests library, which is the most common way in Python to access data on the web. And a lot of that data is going to be in a very particular form called JSON, and we're going to show how to parse that. So why would you ever use an API? Well, sometimes you don't. You might download data manually from a website, click through a series of links, and save a CSV or a similar file to your hard drive. But application programming interfaces, or APIs, make it possible to request just the data that you are interested in. And sometimes that's static. It's going to be exactly the same every time you request it, like US Census data. It's not going to change. But sometimes, and this is the real power of the API, is it's going to be dynamic. Each time you request data, you're going to get a different answer back. And a good example is transportation data, like bus or train arrival times, or driving times, or directions. So let's look at this BART example. BART's API documentation is pretty well covered in their website. And we're going to look at the real-time estimates. So in particular, this command called etd that requests departure times from a station. And you can see lots of different examples here. And the key is going to be this type of text string. It's just a URL. You could paste it into your browser, but we're going to use the API. So let's do an example getting the real-time departures from 12th Street, Oakland City Center Station. And according to the documentation that we just looked at, the important part is we're going to specify origin equals 12th. And there's another command here called JSON, or another parameter, JSON equals yes, that's going to tell BART that we want the output back in JSON format. Now, often when you're using an API, including BART, they're going to ask you for a key, and that identifies yourself to the developer. They can make sure you're not putting too much strain on their server, for example. And if you're going to do this seriously, you'd probably request your own key from BART, but for experimentation, BART provides one on the web that anyone can use. And this is what I pasted in here to our code. So we construct this request by simply building a string that contains all of the commands and parameters following the example that we just looked at on their website. And then we're going to pass that string to requests.get. So we're building up this request string. I copied and pasted most of this from the website, the etd command, or estimated time of departure. The command is etd. Our origin station is 12. We're asking for it in JSON format. And we're going to add, just concatenate the API key, this string, to the end of the request string. So here we've made a request to the BART API and stored the response in this R object. Well, it doesn't print it yet, we haven't, but it's contained there. Now let's see what this R object looks like. Well, we could use the dot notation to see what functions and attributes are there, or we could do help R to see some of the methods and the functions, what's available to us. So some important ones are going to be OK. This tells us if the request was successful. And also the text of the response. That's what we're going to try and parse and extract. So it looks like we got a successful request. And the text is quite a lot here, but definitely there's some information on bikes, on the lines, on the time for departure. So this does look very promising. But how can we get this data into a more usable form? Well, JSON, one of the built-in Python modules, is the key to this. And so I'm going to import JSON, and then I'm going to use the JSON loads function to parse everything that was in our text. So basically all this, this mass of text here. And what does it give us? Well, it gives us a dictionary. I just printed the type there. So I want you to pause the video for a moment and try and figure out how you can access the relevant contents of this dictionary. And a hint, first take a look at the keys. Okay, I hope you had a chance to do that. So let's walk through what you might have done. Well, first of all is to look at the keys. And here it appears that we have two keys, $XML and root. We could look at both of these, but let's take a look at the root item. Okay, and this is where most of the information that we want is contained. Now, root seems to be another dictionary. You can tell this by the curly brackets at each end, and also that there is a colon separates the key from the value. So let's see what keys are there. Well, there's several there. If we scroll through this, we could do trial and error, or we could just look, and it seems that most of the information is in the station key and the value, which is all of this and beyond. So let's go one level down. We get a list, and it appears to be of length 1. So I just did the length of all this item, which was the list that's contained in the station value. So what's the first element using the subscript 0 or 0? Okay, again, most of what we want seems to be there, but it's another dictionary. Again, you know, because of the curly brackets. And most of the information here, again, we could go through these keys and print them and do some trial and error. But looking here, most of the information seems to be in this ETD, Estimated Time of Departure dictionary, which looks like it gives us another list, and you know that because of the square brackets that enclose it. Okay, so this is another list, and each element seems to be another dictionary giving details of trains to a particular destination. So rather than keep adding on to the end of this, let's simplify things by pulling this list out to a separate variable and calling it ETD. So rather than keep on adding subscripts or brackets to the end of this, let's work with ETD. Now, what's the first element of this ETD? Well, it's a dictionary, and it gives us a destination and an estimate. So this is what's contained in destination, and this is the estimate, which is yet another list with a dictionary contained within it. And then this is a second element of the list. So it looks like each element of the list is giving us trains to a different destination. And we can print this more nicely using the format method for a string. So what this is doing here is we're printing this text, and then the curly brackets are placeholders. What does it insert in these placeholders? Well, it goes to format. The first curly bracket we're going to substitute in this, and the second curly bracket we're going to substitute in this, or the number of minutes. Okay, so that's a lot of layers, and that's kind of confusing to go down layer by layer. So one way to make this a little easier to work with is to convert to a pandas data frame. Sometimes it doesn't work, but the pandas data frame constructor is pretty smart. It can take a range of formats, so it's always worth a try. Okay, so here we see it worked. And so this first set of estimates, notice this is only the trains to the first destination. You can see there's a train arriving in 7, another in 22, and another in 37 on this yellow line. So this is only the first destination. Remember, ETD, go back and look at it, it was a list. And we'll have to loop over ETD to get to the other destinations. So we could use print, but here I'm going to use display to format the output a little more nicely. If you want an explanation, you can click on this link here. So for each of these elements in this list ETD, I'm going to extract the destination and print it, So this is Antioch, and then Berryessa, then Millbrae SFO. And then I'm going to display, or basically print, the estimates for trains going to that destination. So E is going to be a temporary variable that just contains each element of the list of ETD. And there's 2 more destinations too. So I want you to stop the video for a moment and see if you can figure out how would you calculate the mean headway, or in other words, the time between trains for one of these destinations. So here at San Francisco Airport, there's one coming in 4, there's one coming in 10, another coming in 26. How would you get a mean of these, the time between trains? It looks like the first one's a 6-minute gap between trains, and then there's a 16-minute gap between trains. So let's recap what we did. First of all, we constructed a text string that was following the API documentation that Bart provided on their website. We created a string, and then we passed that string to requests. And then we did a lot of step-by-step detective work. We kept on going one layer down into the output that we got back to figure out where the output that we wanted lay, and then we converted that output into a usable format, a pandas data frame. So let's focus on the first step and try more commands from the Bart API, such as returning fare information. So this is similar to the ETD command, but we're actually asking not just for an origin, but also a destination station. It makes sense, we need a fare between 2 stations. And then there's some optional commands, not optional parameters rather, including the date, the schedule, and we can ask for the response in JSON format. So we're going to add these various inputs separated by an ampersand, an and sign. So for example, if we want the fare from 12th Street Civic Center to 12th Street Oakland to Civic Center, we're going to use the same base as before. We're going to add fare. Then we're going to say our origin is 12, our destination is Civic. Our key is, this brackets are a placeholder for the API key. And then we're going to ask for JSON. So here we pass this to requests, and this is what we get back in response. And interestingly, it's exactly the same, our output, if you paste this whole request string into a web browser. We're going to get this back instead. An alternative and more elegant way of calling requests is to put all of the inputs into a dictionary. So we're going to, rather than having this really long string, we're going to create a dictionary that's called params, or parameters. So we saw that we had command is fare. Well, let's put this in a dictionary. The key is command, and the value is fare. Origin is 12th. Destination is Civic, and so on. And then we have a much shorter string, so this request string is going to be just the base. We don't actually have a placeholder, so we don't even need that. And then our parameters are going to be passed in this dictionary. And we get a missing API key. Let's try that again. OK, with third time lucky, and we get that back. So I'm going to ask you, before you end this video, to go and explore and go and experiment with some of the other APIs in the Bart documentation. So what do we have? We had ETD, but we also have some APIs for schedule information, for station information, and so on. And I'll leave you with these takeaways. But while APIs might seem intimidating, really they're just text strings that you could paste in a web browser often, or you can access using requests. You can build up these strings step by step. Often JSON is what they're going to give back to you, but you'll often need to experiment. Again, detective work is the key here. Look at the output, going through it step by step. And then the final thing I'll add is be nice. Don't try and overload someone's server, or if they slow you down, don't keep making lots of requests. And some APIs will ask you to register for exactly that reason. Again, most will kick you off if you're too aggressive. If they kick you off, wait a bit, slow down, take a breather, ask for the data at the pace that the server is comfortable giving you it back.